KAT6, and when we first were diagnosed, there's two versions of it. It's KAT6A and KAT6B at this point. We were diagnosed, Jack was diagnosed with KAT6A. And effectively how it was described to us is within the genetic code, you have proteins. And the KAT6A protein, let's say, is this long. A mutation of the KAT6A gene or protein makes it maybe this long, or this long, or this long, or this long, or this long. So it manifests itself very differently among patients. You know, some children are wheelchair bound and will never walk. Some children, if you just saw them walking down the street, they have KAT6A and you would never know until you maybe really interacted with them, or you might think it was autism or some other type of disability. So it presents itself so uniquely, and that's one of the challenges to actually having it diagnosed, is it's not apparent just from looking at somebody.
And one thing that our geneticist described to us when she found the KAT6A gene was mutated in Jack was that the only reason she really knew to look for that was because she was looking at other patients out there who had similar traits of Jack that led them to their diagnosis. So it isn't necessarily, I mean, now it may be more so, but when Jack was diagnosed, it wasn't a common gene that a geneticist would necessarily look at to see if it was mutated. She had to look at his physical traits to then sort of narrow it down. And you did ask about how one gets it. There are two ways. It can be passed down if you have, if you are an adult who has a mutated KAT6A or B gene. However, more common than not, it's de novo. So it is a random mutation that there's no rhyme or reason why one gets it, or so they've told us so far.